Hi guys, it's been a while, hasn't it? Don't worry, I've been actively working on the engine and it starts to show results. From sprite sheets to GUIs, we have a lot to cover today, so let's get to it. As you could tell from the last devlog, if you didn't watch it, go see it after this video. The first thing I'll be working on are sprite sheets. I've said that hard coding the texture coordinates was a big mistake on my side, but why? Let's first understand how sprite sheets work. Sprite sheets are no different than your normal texture. The difference is that they contain multiple images on one big image. That's where the name comes from. It's a sheet of sprites. To get a specific image in the sprite sheets, you need to know the dimensions of the image and the dimensions of the sprite you want to render. To get the sprite, you need to offset your texture coordinates to match with the position of the sprite on the sheet and then divide it by the width or height of the sheet to get normalized values. To render the sprite, you make your entity with the whole sprite sheet as a texture and use the texture coordinates you've just created to get a single sprite from that sheet. The coordinates are smaller than the whole image, so you're hopefully only rendering the sprite you want and not the whole sheet. And that was my problem. By hard coding these values into the renderer, my program rendered the whole sprite sheet and ignored my pre-made coordinates. It took me a minute or an hour or two, but we can now use sprite sheets and greatly increase the number of textures we can render at any time in our game. While I was working on the sprite sheets in the renderer, I finally decided to properly implement batching. It is really simple. I don't know how I couldn't understand this last devlog, but okay. I've talked about the fact that batching is the act of rendering multiple objects via one call to the GPU, but how do you put the stuff into the batch? That was the question I was asking myself last devlog, and I finally got it. Batches are really like a container or stack that you can push stuff into and not pop, usually. For every piece of geometry you want to render, you call the renderer, which pushes it into a batch that is currently not full. And it works even if the objects are not positioned one after another, because we have previously told the vertex array that every 32 positions in the vertices buffer, a new object appears. Great, we've made sprite sheets work, we've made a proper batch, and I've made a shittiest camera API. Like, look at that! Why are there so many arguments? Why is there an enum? And why do I have to make so many functions? Anyway, what's the next point on our check? Oh. I've been putting off this thing for a long time now. I've added scenes to my engine in the first devlog, but I've actually been writing the code in the init file for the whole time. Why? I don't know. Probably because I had problems with the linker while I was trying to push the code into the scene files, so I decided to ignore it until it became a huge problem. But I finally need to step up to the challenge. I want to add GUIs and they would fit perfectly if I had different scenes. After a bit of procrastination and crying in the corner, I started working on it. Firstly, I changed my scenes and components to work with the update pattern. Because I was working earlier in the init file, I could put all of my stuff in the main loop, but because of the obvious reason, I can't do it anymore. Update pattern is really simple to understand. Instead of the main game loop being flooded with every single component, game object, etc., that want to be updated this frame, we give each scene one update function which will run in the main game loop. In the scenes update loop we have game object that call their update loops, which can update loops of every single component the game object has. It might sound like a total overkill, but because we've made an update method for every individual component in the engine, we've got two benefits. Firstly, the main loop isn't clustered, and secondly, because the update loops are specific for each component, we can put the features on the component and micro-focus on these small update loops. If you want to learn more about update pattern and many other programming patterns that I probably should use but I don't for some reason, go check gameprogrammingpatterns.com. After the fun stuff, I had to finally start moving my code to the scene files. My first goal was to get the shader to work. Not specifically to render textures, I just cared about the colors, because it would be easier to do that. For some reason though, I had troubles with the shader class. It removed itself, changed its ID, and did a lot of weird stuff. To this day I don't know what was happening. So how they solve this problem? It's pretty easy. I did the same thing every programmer does at some point. I added a feature that would hide my lack of understanding of a topic by doing some magic stuff. In this case, I used something called object pool. Again, check game programming patterns. In my init file, I defined a shader and pushed it into the object pools array. And when I needed the shader, let's say in my scene files, I could get it by referencing the singleton class. And it worked, for some reason. The next step, and the last step, finally, was to get textures. I thought it's gonna be a piece of cake. I mean, I've already added a shader class, which is basically the same thing, so what can stop me? Oh, so it doesn't work. And that was my problem with textures. When I worked with the shader, I could at least see that the ID is broken, or there is no ID. But with textures, I would just see a black void that sucked all of my enjoyment and happiness for a whole 2 days, while I was trying to do absolutely anything. But then, when I was brushing my teeth, which guys should all do, I highly recommend that, I thought to myself, yeah, I made a texture, but I've never pushed it to a uniform, didn't I? What's so important about uniforms? What even are uniforms? In simple terms, they are functions that can pass data from your usual .cpp files to the shader code. The uniform that I forgot about was pushing the texture index and data to the GPU. That means that if I had a texture that was bound to index 2, which means that if I ever used the number 2 in the context of rendering textures, I was talking about that specific texture, the shader code would render the proper texture based on its index. And if I never push the data to the shader, yes, the index was -1, or something like that, I don't actually know the specifics, and it would render the color black. Very cool OpenGL, and this is why you should never trust your brain to remember about those small snippets of code. Never trust it! Oh, and I added I'm GUI to the engine, but it kinda looks like poop now, so I'm gonna improve it and show it in the next devlog. So go watch my other devlogs, they are pretty cool. Also you can check my shorts, I think they are also kinda okay.